Scripting is really big, and even today I'm not going to finish it. There'll be some left over for next time. But I must say I have a lot more sympathy for developers. The whole book makes me feel more sympathetic for developers, especially 80% of sites being vulnerable. There are so many ways to do this. It just makes me sick to imagine you're actually going to stop them all, and nobody does in practice. So the basic idea to find these things is to stick in a string here. This is the simplest one. For the simplest kind of cross-site scripting, which is where you put something in a parameter and it's echoed back to you without modification and executes, you can put in something like this. And that's fine. That would work in the simplest case. And that's the fastest. And so he says, if you just want to exploit an app like you're a pen tester, you just write a script or something, try this in every parameter and find one that is this simple and use it. That's a way in. Now that is not the same thing as finding them all with the hopes of fixing them all, which is another issue. But if you just want to get in, finding the simple one that's easy to use is the simplest answer, because there are probably so many that some of them are easy. But if you don't want to use one of these easy ones, or if by some miracle you actually find an app that doesn't have one of these easy ones, there are a bunch of ways to sneak in ones. So the reason they might not let you do this is because they have some degree of blacklisting. They remove the script tag or they remove the special characters, and so now you can try various kinds of crafted attacks, like you can URL encode %3c and %3e for less than and greater than. You can change the case in the letters. You can add a NullByte at the start of it, so hoping that the filter was written in C and it won't see the attack string because the NullByte will terminate the string, and so on. There's just a lot of tricks. All right, and so if the simplest thing you look for in cross-site scripting is that I send the server something and I get it back unmodified. But sometimes you get it back modified because they made some attempt to sanitize it. Now, in general, this just seems very unwise to me, but there's two practices that make it almost impossible to stop this. One of them is developers have a practice of taking data, deciding it's bad, cleaning it, and continuing to use it, which is kind of screwy. I don't know why you don't just reject it and pop up an error message, but I guess people don't want to break the flow of the app or something. Another thing which is much more of a problem and impossible for you to fix is HTML itself. HTML is an appalling language. And there are two huge problems. One is that there's all these old versions of HTML and it keeps changing. And a lot of people have old browsers. So every browser has to support all the old versions. And every browser has to support unknown new tags because the language will keep evolving, so your browser will see things that it cannot understand, and it has to not complain about them because it'll say, well, that might be some later thing added to HTML. And what's even worse is there's a giant legacy bunch of pages on the internet with rotten coding. And your browser attempts to fix the bad code and displays it, which is insane, but that's the way it really is, because it's like a television. I want to see the picture, and if it's not perfect, I don't want to see an error message. I want to see as closest approximation you can get to seeing the picture. So each browser has an engine that tries to rewrite bad code, and they make different random assumptions there. And a more controlled language like C would just have a compiler, and if anything's wrong, it won't compile, and you have to fix it until you get in code where there's just one way to interpret it. But browsers don't have that luxury. They have some poorly written page, and they have to show you some version of that page or the customer won't be happy. So they make random guesses as to what you probably meant to put on that page when they hit things that don't work. So anyway, you might get a modified input string that's been decoded or cleaned, and you might, in document object model based XSS, you might not see the response at all, but it is stored somewhere in a DOM object that can be referenced later by JavaScript. So if you want to find reflected cross-site scripting vulnerabilities, the simplest kind, then you put in some kind of alphabetical string. Find every place where that alphabetical string comes back to you, and this is easy to do with a script, of course. Find the parameters, feed the parameters, look in the response for it. Every time you do this, then you're going to have to look at the context because you want to see if it came back inside a script tag, inside an image tag, just in the main body, and each one of those affects what kind of tags you want to inject to make it work. Then you try to figure out if it's been sanitized or blocked and try to understand what the filters are doing and how to get around them. So you want a unique string. You don't want anything other than alphabetical characters in it because they might be filtered. You don't want any punctuation marks, so you put in something like this, my cross-site scripting test, and a few random letters. Then you put it in every parameter and also in headers like user agent and refer. and you watch the response for any occurrence of that string. And anytime you get one, you have some degree of cross-site scripting there. So now you have to go back and basically test them by hand to see if it's exploitable. Only the simplest case could actually be automatically exploited. Most of the time you have to read the code and figure out where you've injected something and what the context is, and therefore what characters would have to be added to make it add up to the script that does something you want. So if it comes back as an attribute, for example, so here it is, my XSS test. So I put in some parameter, and it came back in the value inside an HTML tag. So here's some ways to exploit it. One is to close the quote, close the tag, and end this one. Now inject another tag. Then it's going to have some junk at the end, an extra quote, and an extra greater than sign, but none of that's going to matter because it lets you get my script before it gets there. And here's another one. You can add another tag on focus equals alert1, and then when someone moves the mouse over it, it will pop up. This is not perfect in some sense. You could call it social engineering because the user has to do something, but it's something that's not too hard to get the user to do. All right, so let me open up a few of these. Let's look at them. I got them all up, and that's of course the next homework to play with this thing. So first, I'll do what you might be tempted to do, which is open it in Firefox or in Chrome. And you will discover, as we did before, that none of this stuff works in Chrome very much. So not that one. I need to refresh this page. There we are. That's the new one. All right. So here, for example, is the tag attribute value. So you can resize the image here. So it's right, if I make it 50% and 50% and submit it, I get an image shrunk to 50%. And if you look at the page source, it's got height equals 50%, width equals 50% in single quotes, and this is something under my control, and that is something under my control. So I can inject evil things into there. So I can inject this 50%, and then a script. That's the first one they have there. So I put that in for, say, the height, and submit it. Now I don't get anything popping up. And the reason I don't is if you view the page source, it turns red on me here. See, it worked, right? I have image source equals height equals 50%, close it, script alert1 script, and then some junk over here which will just print literally on the page and not be interpreted as tags. It should have worked, but it didn't, because if you have this thing here and you right click inspect, it will tell you token contains a reflected XSS vector. This is Chrome. Chrome has anti-XXS features, so that protects the end user and decreases the value of these attacks, although there are attacks to get through, which we're going to see later. But it means when you're trying to just find vulnerabilities and develop exploits, you'd be a lot better off to use Firefox. Firefox is the only major browser I found that does not contain any protection. I imagine that is because they don't want to have automated protection. So I'm also going to just go to attack direct, so it's not a secure page, just for convenience. Anyway, it's important for that one. It's not so important for this one. All right, so now let's get back to this thing, 50%. So in Firefox, you can take this thing and put it in there. Yes. Oh, and it's probably going through burp. Probably going through burp. Let me just bypass burp for the moment. I'll just run burp. Is burp running? Burp is running. It's probably got intercept is off, intercept is on. I probably gotta restart burp or something. Because the proxy used to be going on a different network adapter. I'll just close burp and restart it. There's probably some way to tell burp to refresh my network connection, but I don't know it. Yeah. Maybe I should update it. I don't know. I've dealt with enough products that get worse when you update them. I'm very suspicious. Anyway, all right. So let's go back here, refresh this thing, submit this thing. Well, there's stuff. Okay, it's going through, theoretically. Right. All right, let's try bypassing burp and see if I can get something to work around here. Probably I need to, I don't know what I have to do. Let's see. I'm still on the internet, I think. Okay, I'm on the internet through the wireless connection, so there should eventually be some way to convince Firefox to knock this off and let me see the page. Okay. All right, let's quit Firefox and restart it, see if that does any good. That's going to be annoying if nothing's going to work. Let's try AOL.com. All right, that's a good start. Now, attack. Okay, let's try the encrypted version and see if that works. Oh yeah, college has like layer 7 firewalls and stuff that might be in the way. All right. Ah, there we go. So it pops up the box. That's what I wanted to see. And so the point is, it works, and this is just working because it's Firefox. So that's the sloppy one that leaves some junk floating around on the page, but it did execute the code, and that's all I really care about. Here's the other one that doesn't do that. And when you move here and click on that, it pops up. I found that on Focus didn't work, but on Click worked. Anyway, that's the game, and if you look, it's now is a perfectly reasonably formed tag, source equals, height equals, on click equals, width equals, usual stuff. All right, so here's a JavaScript string. Here's another, so this one here, let's put in foo, and if you look at it here, view page source, well, not that, view page source, okay, this one ends up in a variable A equals foo, which is not printed to the screen or anything, but it does come back. I put in foo, and foo came back in the code. It's in the value of a variable. So again, you can exploit it, but you have to write your attack tag carefully to match the conditions. And this is the one. This attack tag will finish the variable, then have alert one, then go on variables. It doesn't put in any script tags because it's already inside script tags. And this is why this one, for example, if someone is filtering out script tags or less than or greater than, it won't do them any good because the data I put in is actually coming out already in a script. So that will do it again. And you can see here what it did. View source, if I can get this thing to work. Why don't I see view source? Okay, it's down here for some reason. All right. And that's the game. It just has now a series of JavaScript commands inside script tags. All right. And here's another one. The parameter you put in might come out as a URL. So if I go to this one, it's got a click here. And if you view the source, that's just ahref equals something click here. And I'm able to control that. So once again, it's not difficult to do. It's just as why you have to do it by hand because it depends on the context. Now you have to complete that. So one simple thing to do is put in the URL, then add an on-click tag inside there. Then add your JavaScript in there. There are many ways to do it, but that's one way. So now that click here link now has a second method that will cause this to pop up, and then after you click OK, it'll go to that other page. So I said not too complicated, but it is not something you can easily do automatically. So that's the game here. If you're inside a parameter, you just finish the tag. And if you're in a URL, there are various ways to do it, but one way to do it is to add a handler, on click equals JavaScript alert. Use JavaScript just like a protocol. JavaScript colon like HTTP colon. You can make a URL. And that, by the way, that would be another one to do it. I don't think I had that in my example, but you ought to try it. Yeah, this one here. I just didn't do it. This original URL is HTTP. Come on, go to the left. All right. And you can just replace it with this URL. JavaScript colon will then take what's after it and interpret it as code to execute, and yet the browser will treat it as a URL. So that will now do the alert. I don't know why I had to click. I had to click there because of the nature of this page. Yeah, it's ahref equals JavaScript alert, and going to that URL will run the JavaScript. All right, so back here. All right, so the next step is to find what filters you have. I remember seeing a fun talk by Joe McCrea about this, where the first thing he would do at every web app is try to do directory traversal to like cmd.exe. And he said, directory traversal never works. It hasn't worked in decades. I'm not doing it because it's going to work. I'm doing it because the error message will tell me what brand of web application firewall they bought, and I know how to get through them. And web application firewalls are typically pathetic. I think they might be a little better than they used to be, but they're typically incredibly stupid. Vulnerable to all sorts of tricks like just changing the case, adding extra spaces and things like that. They typically just have a fixed string of attacks and they remove them as if they were viruses. So anyway, here's the thing. You might have whatever the protection is going to identify an attack signature of some kind and block you, or it's going to take your input and then perform some sanitization and alter it and then use it anyway, which is an appalling practice but commonly done. Or it's going to truncate your input to maximum length, which is a pretty good security measure, although it can be defeated if you're good at writing really short code. So here's an example. You might get an error message like this. This is ASP.NET anti-XSS filtering telling you I found it. A potentially dangerous request form value was detected from the client. So that's telling you, of course, you got busted. So the logical thing to do, this is how I debug almost everything. When I'm in languages where I can't really see error messages or anything, which is very common, if it crashes, I cut the code in half and put in just the first half. Does it still crash? Then cut it in half again. Eventually you narrow it down to what part of it caused this. You'll eventually find what caused it. It could be something like a script tag that caused it. And now you know what part of it is illegal. Now you have to find alternatives to sneak in that thing or some way to live without it. So there are ways to sneak in script tags. If script itself is blocked, then you can try some of these tricks, and I'm just going to try them live. I've got this set up as a demo here. All right, so here, if I just try to put in usual things, script, alert one script. Well, let's be a little more orderly. If I put in foo and submit, it's right there. So this is a very simple case where the tags appear right on the screen, not inside a parameter or anything stupid like that. Okay, so in that case, the logical thing to do is put in that script. That'll do. All right. Script alert your name, submit, and it doesn't run because it detected a tag and it busted me. All right. So now I know the script tag itself is breaking it. So you could try, for example, using an object tag, but it still contains the script tag inside there. So they'd have to be pretty sophisticated and stupid to fall for this. And in fact, they will catch you because it just still has a script tag in there. But this one here is pretty good. I didn't know you could do this, but I should have known this because I've seen this sometimes when you view an image in something like Wireshark. You see all this base 64 go by. You can put text HTML base 64. And what is this junk? Well, that junk, let's go to base 64, decode. You can do it with any convenient language, but you can also do it easily online. So let's find out what that junk is. Let me put it in here because I got it in clipboard. All right. Now let's get just the base 64 junk. And in case you're not good at spotting it, base 64 is easy to spot because it has capital letters, lowercase, and numbers, and it usually ends with equals. The equals are not always there, but they're there 2 times out of 3. And you just get to where you can spot this really fast. It's not an MD5 hash or anything else. That's base 64. And so if you want to decode it, I can put it in here and decode it. And that is script alert one script. Okay, but you're in base 64, so it'll bypass a lot of filters. And of course, it does. The filter cannot figure that out. The developer did not think it might come in this form and decode it first. Yeah?
Yeah, from my experience, about 95% of all the injected stuff on defeated pages injected with base 64 encoding.
Yeah, and almost nobody can catch this, right? You'd have to think of it. It's like there was a time when antivirus didn't know to look inside zip files. And they wised up, but now they have a handler, and they have a handler for this. They have to add a handler for this to their defense. And
I just don't know why in the first place they make it, base 64 enabled.
Yeah.
What was the reason to do that?
Yeah, I mean, another way, which would be simpler, would be to just not accept base 64 input, where you have this thing accept in your server. But, big sprawling applications use these things everywhere. That's the thing. And of course, the primary design focus of the developer of the security product is not to break your thing. And also, people will tell you cross-site scripting is low priority anyway. So it's really not worth working hard to stop it.
You can inject whatever you want this way. So
it is by itself, cross-site scripting is considered low priority because it does not directly steal the data from the company, but in practice it can steal authorization tokens from anybody, and they can be administrators, so in practice it can lead to the same kind of disasters as other phones, but it's traditional not to pay attention to it much. So you can do it this way, and you can just send it in an object tag, and then it will appear. You can also, of course, put it in a anchor tag, and then it will create a link to click, and when you click the link, it'll do that. So, and all this without having anything looking like a script tag go by for the developer to filter out. All right, let me go back to here. All right, so now these event handlers, like the ahref I had there, you had to click on it to make it happen, and that's kind of unprofessional. The user might not be clicking on it, you might be exploiting something that's just sitting there without a human in the loop. So there's a bunch of other ways to do it. XML has some, and style that has this thing called on-ready state change, which I don't know exactly what it means, but in practice it seems to be something like on load, where it's something that happens automatically when the page loads, so it'll then do it. You have object on error. This is a pretty good one, or image on error. These are cool because then you just put in invalid parameters, that causes an error and it runs the on error. And here you got the on-ready state change and so on before reactivate, non-activate. There's just lots of things here. Any tag and these many event handlers will let you put script in your tags and some kind of condition that you can arrange to be true. HTML5 adds another bunch of them. You've got autofocus, which is even more fun, so you can have autofocus and then onFocus do something. So that'll do it. You can have on blur, alert one, and autofocus, and on you go. In HTML5, you can put handlers in closing tags. I don't know why, but you can, and it's another place that your filter might not have thought to look for them. And it's got new tags, like video and audio, which is the main advantage of HTML5 I know. And you can put handlers inside there. So again, that will fool systems that are not fully HTML5 compatible. Even if they're doing a good job of scrubbing, but they don't know HTML5, they won't know to look in there. All right, and then there's pseudo protocols, where a URL is expected. Like I say, JavaScript : is one of them. Internet Explorer used to allow the VBS. Well, it does still, but Edge no longer does. That's Microsoft's Visual Basic Scripting. Boy, there was a time about 5 years ago when these things were all the rage, because your average browser supports about a dozen of these protocol handlers, and a bunch of them are never used anymore, like TEL to dial the telephone, mail2 to send email, and they weren't filtered at all, and you could just totally sneak things in through them. There were a whole bunch of exploits based on them. Anyway, here's HTML5 with more tricks. You put form action JavaScript alert there, and event source and so on. More ways to sneak in handlers. And then there's dynamically evaluated styles. So your style can be calculated from an expression in earlier versions of IE, and in later versions you can still do it with a different format. I don't know if Edge still allows this, but you can now calculate styles, and therefore you can calculate something that adds up to a script, and then the script will run. Bloody awesome. Then, so if you want to obfuscate this attack, so I got on error equals alert, and then I have source equals A, an invalid source, so it won't find the source, that'll make an error and it will run. So now if they're blocking that, I can just try changing the case I capital M G in case they forgot to make their grep case insensitive. And then you can stick in NullBytes. And in your textbook, they use these square brackets around the NullByte. I don't know why, because the %00 is what you really put in for an encoded NullByte. But anyway, you can put a NullByte in, and a lot of browsers will ignore the NullBytes, but if the filtering software was written in C, the NullByte will terminate the string and it won't see the end of the string, which is cute. So that's the game here. And this is what you typically have if you're have a web application firewall, or for that matter, I would think it would probably work in mod security. In Apache, that's C code, that's compiled, which is the most popular web application firewall because it's free in front of Apache. Anyway, then you can have invalid tags. Remember, the thing about HTML is it doesn't know the language. Your browser doesn't know the language. It's guessing. It can see things it doesn't recognize, and it doesn't know what to do with them, so it doesn't just give up and quit. So I can have a tag called X that's invalid, and I can have a /X, and I can put text in the middle, and it will, when you click on it, it'll run the event handler, even though it doesn't know what X is, which is pretty cute. So again, it's another way to sneak something in, and your since people are constantly writing new tags, your security device has to not block new tags it doesn't recognize. All right, and then there's base tag hijacking. If you write a page using relative URLs like mine, it's always relative to where the page is. And if you move everything to another server, it'll work. But you might want to have a whole section of code that's coming from different servers, so you'd set the base to point somewhere, and then all the relative tags in there go from there. So here you have script source equals good script. But with cross-site scripting, I can inject a base tag above it, which changes the base to bad scripts. And now they'll get a thing named good script from my bad script repository, not from their local repository of good scripts. And that's cute.
That's used a lot too.
Yeah, that seems like a good trick.
Yeah.
All right, then you can, suppose they're looking for spaces to find the tags, to find things like event handlers. You can make tags with attributes without spaces. You can put other things in the way. Now this is probably an error, but browsers will accept it. So you can put a slash in instead of the space. You can put a %09, which I think is a tab. Here's a line feed and a carriage return. You can put a slash quote in there. And some browsers will take it. You can put a slash followed by name junk and another slash there, and a lot of browsers will ignore it. So, these are things which browsers will let you do, and it will probably follow up the pattern for the grep matches that people are trying to match. And you can also add more characters, script any junk and so on. These things work. I think and then there's NullBytes. You can put a NullByte in the attribute name. Again, the browser will ignore it, but the security product might not. In IE, you can use a quote, single quote, or double quote, but in IE you can use a backtick as a delimiter, and it will accept it. Other browsers won't. And again, it might fool your filter. So if the filter is unaware that backticks are delimiters, then the filter will interpret this as just the source name, all this junk, backtick A, backtick on error equals alert, that's all just a name. It's not a separate thing called on error that will have any results. So that's a cute one. I think I got a bunch of these. And the thing about these, they don't work in every developer. They don't work in every browser, but they work in some. So here's obfuscation, these various types. So here's the simple one, simple reflected SSS. This is Firefox I'm using, which is usually the best. Here's this XML tag on ready state change. And as I remember, this one did not work, not in this position. And I don't know enough about XML to know why. I wonder if you just have to slash XML somewhere. But I don't know, it did not work in mine, but it probably works in some browsers. Yep, anyway. All right, input autofocus, on focus equals alert. I think this one also did not work in Firefox when I tried it. Nope, it works, okay. So here's on click with the unknown tag of X. So I got X, I got click here, then I got /X. It does not highlight the text because it's not in anchor tags, but it still knows it's clickable. When you click it, it runs the event in. Here's junk, just after a slash. I really don't know why this works. The slash is not a comment, or we ignore all this. I would like someone to explain to me what they're thinking about ignoring that there. But the fact is, it works. You have to go more deeply into what logic there is in browsers, why it would ignore that, but it does. And therefore, you can do this sort of thing. You can put it in an image tag. And now the slash here is interpreted as a delimiter. Oh, I guess the previous one probably interpreted as a delimiter, then had any junk, which it interpreted as an unknown parameter, which I guess that must be from some later version of HTML, so I'll ignore it. So I guess that's the logic. Anyway, that's the game here. So now that's the one that works, and yet the protocol handler will interpret this as just one long unbroken string. Anyway, all right. Here's... This one's cute. If you put in double tags in HTML, again, browsers accept this. Again, I don't know why, but they'll let you do this, and it runs. Not in this browser. I thought it ran in the last one I tried it in. Anyway, some browsers will supposedly accept that. And here is something that has a funny acronym describing it. This is some other kind of HTML syntax, which is supported by some browsers, where instead of closing the script tag, you open another tag inside it, put in curly braces, and put the script in there. And I think this one doesn't run in my Firefox, but it runs in some browsers. And we'll get to this other stuff, like we go back to the slides a bit. All right, so those are your crazy delimiters. In your values, if you had to go to your value, you can put in null. You can also HTML encode characters. So here I got ALERT. The L is ampersand pound X6C, which means hexadecimal character 6C, which is an L. And the point is, it won't look like an L, so things looking for alert and trying to block alert. You can then HTML encode any characters you like and scramble this thing up to where the less than and greater than signs are HTML encoded and so on. And this will work if it's HTML decoded before use, which it almost always is, and sometimes twice. So there are many ways to do HTML encoding. You can insert a leading zero or multiple leading zeros and it will accept it. You can put it in, get rid of the X, and now you're in base 10. So instead of 60, it's 108. For the L, you can, and I think this just had a leading zero, and on you go. There are just many ways to write it, and that's why, you know, the poor guy trying to write a regular expression to stop this has got a really miserable job. There are so many variations. Then, some apps perform URL decoding twice, and I would think this would be even more likely when you have multiple servers and boxes it's passing through. So then, you've seen this is real old attack in Internet Explorer or IS3 or IS4. You use this %253C because the %25 will decode to %, and now you have %33C, and that will decode to less than. So you feed in a doubly encoded special character, it gets decoded twice and has the effect. That, of course, relies on some degree of mistakes being made, but it is a fairly common mistake people make. Then, this is even more nuts. Oh, this one only works in some applications. It doesn't just work right in Firefox. This is where you take special characters from foreign languages, and to make it, instead of actually supporting a foreign language, you just convert them to an ASCII equivalent. This is a really bad idea. So you take these things, which are like some quotes in a foreign language, but you turn this into greater than and that one into less than. So that's, apparently some people really write things this way, and I can see this is like, I know people that do this, they want to like display it on the screen, and they only support English ASCII, so they'll kind of character that looks close and put it in there so it'll look about right on the screen. This is, of course, a miserable idea. There were a bunch of these. Remember, there's one that came out a few years ago where people bought PayPal, but they chose an A with like an umlaut on it, a foreign letter that looked kind of like an A that was frequently drawn as an A by American browsers. I think IE did that. So you could buy domain names that would look exactly the same as real domain names. And I remember IE actually fixed this by stopping all support for foreign languages between two patches, which was a really drastic solution and not popular in Europe, but it did fix the problem in some sense. And people were staring at them for that, but there was a fake PayPal up there and people were losing money, and that was their fast fix. Anyway. So like some browsers tolerate extra brackets. Firefox supports this thing, supposedly. Oh, it didn't work when I tried it. You can put, now like I say, Firefox and other browsers will take your code and they will rewrite it before rendering it. And you can put an add-on in your browser that will show you what the rewritten code looks like, which is pretty handy. So you get this web developer add-on, and now you get a button view generated source, and you can see it. Now, from what I read on like Stack Exchange, there are versions of this for each browser, and none of them actually work. They all show you generated code that is not really exactly what the real code does, but it's close to it. So this would help you make plots like this evil stuff, make a page full of these weird characters and see what it's going to turn into in the browser. This is just madness. Remember, I used to work at a company and there was this, I had an assistant and they kept saying, fire the assistant. I said, no, I love this assistant because they never just make up stupid things. When she doesn't know what to do, she asks me. This is very valuable. It makes me very nervous to have something like a browser saying, oh, you meant to write this, I'll just do that. And I go, wait, I wish you would just pop up an error message instead of just changing what I wrote into what you guess it must be. But anyway, that's what it does. Anyway, so then there's these goofy character sets. Now, most of the time you use US ASCII, which we're used to. It has these hexadecimal codes for characters. There's something called UTF-7, which I do not understand, 7 bits per character, and yet somehow you write plus ADW minus to make a less than sign. So I'd have to read that up on Wikipedia and find out what the heck is going on here. But anyway, there's another character set that does let you write this stuff using goofy things, avoiding the special characters. And UTF-16, of course, is very common, Unicode, where you use 2 bytes for every character. And if you have normal ASCII characters, every other byte is 0. And if you have other languages like Japanese and Chinese and Arabic and stuff, it has enough characters to support all the characters up there. So, and all these are supported by your browser, so you could sneak in your attack this way, but you would have to somehow tell the browser that you're using that character set, and that is not always possible. But it might be possible if you can control the content type header, which is where it belongs, or you can use an HTTP meta tag, which adds it in later, lower in the page, if you can inject that, or a char set parameter if there is one being used. Anyway, there's something called Shiftjis, which is a thing where you can mix 2 character sets together. And so here's an example of when you would get away with this attack. You control the input here in a tag of an image, and you have another input later that's just in the body of the code. So the first one blocks quotes to stop you from injecting other parameters, and the second one blocks less than and greater than to stop you putting in scripts, which would be fine. But if you put this in for input 1, that switches it to 16 bytes per character for the next character. So you put that into place of input 1. Now the quote and the right tag here will now be interpreted together as a 16-bit character, which will be some bizarre character that is not a meta character and does not end the image tag. So all the rest will be interpreted as further parameters to the image tag, and then you can add one out here. So that's cute, and you know, it's one of those dirty tricks. All right, so then there's script code. You can, if you actually are able to inject inside script tags, which is not uncommon, then you can use JavaScript functions to obscure your stuff and unobscure it. So this is what Unicode looks like. \U006C is the Unicode encoding for an L in alert. So you can write it that way, or you can create it with other functions. Eval is the function that evaluates the code inside there and puts the result in, like backticks at the bash shell prompt. So here you're going to evaluate it. Here you're going to evaluate it written a different way, %x6c, and here you've got it in base 10. And all of them are going to add up to the same thing. You can also put in extra escape characters all over the place, because escaping something just means it won't be interpreted as a special character. And the browser will ignore it, and it'll break the patterns that people are trying to match. All right. And then you can dynamically construct strings. I've seen this one a lot in PHP malware. One of the more common attacks I've seen a lot is where they have a long string, and then you just pick letters out of the string and scramble them around to build the code they want. Here you can do string from char code and just list the character codes. Here you can add 2 strings together, al plus ert1, so the actual string alert won't be sitting there. And here, of course, you can use this atob function. The atob function converts alphabet to base 64. And it's supported by most browsers now, so in another way, you can inject all that base 64, and the poor guy writing filter code would have to think of all these things, which is sort of superhuman and insane. Here's alternatives to eval. Here's where he snuck in the eval by having a replace function that's going to replace the first character with eval. So before the alert, an eval will appear. This guy's going to have a function there, which is going to end up acting like eval. And if you can't have dots, so you can't make document.cookie, there are other ways to refer to objects. This is another way to refer to an object in a document object model, and there's another one with document cookie. So you don't need the dots. All right, and for real fun, you can mix them all up. So now, this one took me a while to work through. So you got the L in alert is \U0065. But the backslash is a special character, so you URL encode the backslash, and you end up with this mess. %x5c semicolon, that's the backslash /U065 alert. So you could also do that with HTML coding all over the place, and that long mess will be interpreted. So I put that one down here, kind of not believing it, that mess will pop up, but it does work. All right, so let's see what else I got here. Before I go back, let me just talk about your homework. I wrote a couple, this is the last homework in the class, and it's following the pattern of what I've been doing here. Oh, this is Firefox. No wonder nothing is normal. Okay. So let's go here. All right, here's project 15. And I put the extra credit part in the second project just because I had a burst of organization for some unknown reason. All right, so go to those demos and make pop-ups with your name on them. Now, I got examples for the first ones that works. You just have to modify my examples, although one of them requires the base 64 encoding, so you can't be too much of a wimp to figure that out. So get these ones working and save pages where you get those pop-ups to have your name in it. Then that should be easy, and then for the extra credit, you got to do ones where I don't tell you what's going on, of course. So here, you got an error report, and if you submit it, developer was drunk appears up here, and then there's more information down here about the error. And so somehow get a pop-up box with your name on it, and here's the same thing. These all look the same, but of course each one of them has more filtering and abuse, so it gets harder and harder to get the injection in there, and none of these are super hard. But anyway, you should be able to figure them out using these techniques. And all right, I've got a few more things to say back here. All right, VBScript. You can do it all with the VBS handler, but I'm skipping it because it only affects people who are using IE, and IE is already over. It's on the way out. People have now moved to Edge. Microsoft abandoned VBScript like a bunch of their old technologies. It was their competitor to JavaScript, and it never really won. They finally gave up. All right. Then there's sanitization. This is often recommended. Less than should be encoded as %LT semicolon, greater than should be %GT semicolon. So if people are doing that, then that does take those meta characters out of the loop. So if you want to defeat this, the simplest thing is find a way to do your injection without using those meta characters. Now, if your injection is already inside script tags, you don't need to add more script tags. And if you can't do that, then you can try to sneak it in with all these techniques we've been talking about, see if you have some way to sneak it in. Here's one of the many mistakes people have in sanitizing code. If you do a substitute to remove all instances of script, but it only removes the first one, not all of them, then you just put in script twice. It'll remove one of them and it will run. If you don't act recursively, so you remove script and the result is another script and you don't take out the next one. You keep going until you've got them all. Put it in some kind of loop is the right way to do it. That would stop this, but just one removal of script tag will not stop that attack. Then you can have stages. This is pretty tough. So suppose you recursively remove all script tags, then you recursively remove all object tags. You're still not safe because removing the object tag turns this into a script tag and you haven't done that stage again. So I don't know, I guess you got to put it all in a loop or something. It's starting to give me a headache. I don't envy the developers. Then injecting into an event handler here. If you are already in an event handler, and your foo is in there, you control foo, you can put in this attack string, and it will now be onClick equals var a equals foo apostrophe here, and then alert 1. And the point is this apostrophe will be decoded by the browser and interpreted as matching that one in some browsers and terminate this and make this alert happen. But other parsers will see it as just harmless text. And this is the fundamental weakness of having multiple browsers, each of which are making random guesses how to interpret the stuff coming in. All right, then beating length limits, of course, you might have reasonable length limits, like a phone number can only be so long. So you can just learn how to write really short code. There are people who have contests, how short can you make stuff? And CTFs have places where you only have 8 or 10 characters. So this will open the URL A and send the document cookie to it. It's about the shortest way to do that. Here's one that will execute a script from the server, and HTTPA is the source of the script. So those are example really short attacks. And you could go to the JavaScript Packer and try packing things, but if you're packing something like that, it can't really pack it any smaller, but it can pack things and help you. Then another cute thing is, suppose you have multiple injection points. You can put in parts of the script in multiple pieces and comment out the stuff in between. So here's a URL where I've got a page ID and a seed and a mode, right, under my control. So it turns out the page ID, seed, mode just appear in hidden parameters. So now what you have to do is put in, the page ID is going to be here in value. So there I put in start the script tag and start a comment tag. In the next one, I finish the comment tag, put in the alert, and put in another comment tag, and on you go. And the next, so if you add in that junk, it turns into this. And everything's commented out except the stuff in bold, so now I have script alert / script. So, you know, there's a way around anything, or almost anything. If you want to beat length limits, this is a pretty good, remember this document object model based XSS where we take something from a URL and put it on the page. And I said, why would anybody ever do that? Well, even if they didn't do that, you could use reflected cross-site scripting to add that to the page. So put this on the page, and this will now read the fragment from the URL and put it on the page. You've now created a DOM-based vulnerability from a reflected script vulnerability, and you've defeated the length limit, because if you can inject this, there's no limit in the length you put in this fragment tag. And the fragment tag is the part after the pound in the URL. So by the way, if that's too long, you can do it even more short. This way. Here's an example of injecting this. Script eval location hash substring 1 and all that jazz. You can also do this. Script eval unescape location script, and then you add a carriage return, because what this does is this is interpreted as code label. Let's see, HTTP is a label. The / starts a string, starts a comment, and the /h, 08 carriage return terminates the string. So this is, you know, all this is like the code injection we did right at the start. Is the fundamental problem of mixing multiple languages in the same system. This thing it's like you can read it in English, you can read it as Chinese, you can read it as French, and you keep getting different answers. So if this is just raw HTML, this will just be random text. This will be the start of a comment, that'll be the end of the comment, and you end up with the alert there. So it's kind of cute. Yeah?
Can you explain what is the reflected part of the XSS, and there are different types of SSS?
You do. There's 3 types. The reflected part is the simplest one, and that's what we got here, where you just put in code, and the code just appears in the body of the page, not inside anything else. So you print it up, it comes back and runs. And if I was in the right browser, that would work. All right. This is plain old reflected. This is the most common and the easiest to exploit, where you put in text, and the text you put in is just printed right on the page here. So you can just put the code there. You write whatever script you want. That's the simplest kind of exploit. The stored XSS is where you put it in some stored object which is viewed later. Like you put it on your Facebook wall, and people that view your wall see it. And document object-based model is where you put it somewhere up here in the URL, and some part of this URL appears on the page somewhere.
Isn't that what's happening here in this reflected XSS?
It is, but it's not the same. This is just an artifact of the fact that I chose to use the get method to make it easier. Typically you use the post method for reflected XSS, and then you wouldn't see it here. But even if you're using a post method, in the document object model base, there is some kind of parameter up here, like the fragment, the part after the pound, that appears on the page. Yeah, but you're correct. If you use the get method, then there's no logical difference between DOM-based and reflected. Good. Any other questions?
Can you explain also more how these things get injected? Because so far the examples are, we go to this page and we put it in the text field, and then we click the button and then it's getting back to us. But how is this used in the wild?
Well, the way you do it is you do it by hand until you find something. So now I write a script that does something evil, like here, send my cookie to my server. Then I create this URL, put it in a shortener, and email it to people and get them to click on the link. Then they'll click on the link, it'll open in their browser, and if they're currently logged into this service, it'll send me their cookie. That's the most common way to do it. And what's even more fun is if I can somehow make it so that happens without them even having to click on a link. One example in the book is where they found that they could change somebody else's name. So they changed everybody's name in the whole database to their name followed by scripting tags that are invisible. So when next time anybody logs in, their name appears on a screen and it sends me their cookie. So that's the point. We're only doing one part of the attack here. What you're asking is the whole kill chain, and that's also useful. The whole kill chain is where you go all the way to achieving your goal. But this is the essential part of it here, is how cross-site scripting lets you steal cookies is the most common way you get in. But in principle, it's up to your ingenuity. What script would do something beneficial to me? Yeah?
Like recently there was JavaScript-based skimmers for Magento plugin, which is credit card processing plugin.
Yeah.
And it was the same. It got vulnerability where you can inject the script on the page, and then anyone who used that like payment function, there would be like another variable that will store the same and send it to attacker. So one will go through the payment server, another one will be sent to attacker, and that was a big deal. I think even the person who discovered it and put like all infected shops on GitHub, they actually took him down for some reason.
Yeah.
Because like you can't really do that.
Yeah. I mean, that's a big issue. And so the point of cross-site scripting is I can add script to somebody else's site. I don't need to trick you into going to a false site. You're actually on the site, and that site is now running scripts the developer didn't put there. So that's the danger. But I do usually have to trick you into clicking on a link or something. But it's not that hard to do. In fact, I can just send you an email with an image tag that goes to the link, and if you render images, you'll see it. There's just many ways to trick you into going there. All right. Any other questions? Well, I think that's it for today. I'll knock this off. I'll go to the lab and help anybody that wants help there. This is 129S, 13B, I think. That'll do. All right.